This is the Eternity Forge game development vlog number 7, texture atlases, user interface, and hit detection. It's been a while, so I have a lot to talk about in this update, but the major things are, I've switched over to using texture atlases. I've added a message box to the user interface. I've added rudimentary hit detection to the player and enemy entities. I've added a shield stance to the player. I've added decals to the levels for things like blood. So I decided to adopt texture atlases over loading individual frames of animation, and it's actually made my life a whole lot easier. It just makes all the resources easier to track and cuts down on the memory use. If you don't know what a texture atlas is, it's basically you just take a bunch of images and smoosh them together and rotate them. Save all those transformations in a data file, and then use that file to undo all of that madness and draw the image in a game. I'm using Texture Packer GUI to pack the textures, which is pretty good. It costs $40, but it's well worth it if you are going to be packing a lot of textures yourself. Two things I had to figure out in order to do this. First, I had to write a class to parse all the information from the text file that's generated from the Texture Packer. This was easy enough to do. One goddamn thing I couldn't figure out was how to use that data to get the image to draw properly in Allegro. The image wasn't getting drawn in the correct position for rotations. Finally, I looked at the documentation for AL Draw Tinted Scaled Rotated Bitmap Region, or more specifically AL Draw Scaled Rotated Bitmap, and it states explicitly that the point at CXCY in the bitmap will be drawn at DXDY, and that the bitmap is scaled around this point. I just assumed that Allegro would rotate the image around its center point when it rotated it. I'm pretty sure this is what the texture packer does, but instead it rotates the image around the drawing point, which is the upper left corner of the image. So when it comes to Allegro and rotated images, basically what you gotta do is you gotta offset the image by half of the X and Y width and height, whatever the texture packer says is the new width and height after packing it, and add that to the offset of whatever the texture packer deleted, which is what you do for non-rotated images, to get the damn thing to draw correctly. I don't know if this is the case for other frameworks, but most of the stuff you output to with texture packer, Unity, Cocos, etc. seems to do this stuff for you, but there is no output framework for Allegro. Next, I wanted to add a message box to my game. Being a quasi-RPG, you want to be able to see the stats of what's going on in the world. This wasn't very hard to do after I painted the art for the message box. The main thing was adding a message class to my game and dealing with drawing the text and programming a scroll bar. The way I did this is kind of hacky, but it works. Basically, I have 4 positions inside my message box where text can be drawn to. Every time a message gets added, it gets added to the lowest position, and all the previous messages get pushed up. To actually draw these messages to the screen, I just use basic Allegro text functions. But the key point is to use AL get text width on every chunk of text to draw the next chunk in the proper place. As far as the scroll bar goes, all I'm doing is recalculating what messages get drawn into my box in relation to the position of the scroll bar. This is slightly different from how scroll bars usually work, but since I'm only drawing one type of thing to the space, it works for me. The only problem I can foresee with this method is if the text outruns the width of the message box, but I'll deal with that when and if it happens. Hit detection. Right now I'm just using cones to detect whether or not they intersect the bounding box. This seems natural for things like swords, but because of the way I program the geometry, I can also use any line shape in the future. When the player clicks the attack button, it does a hit detection check on whatever frame of animation is closest to looking like a sword hit. Likewise for the rats, it does a calculation on whatever frame of animation looks like the rats are clawing something or whatever. At this point in time, a game message is sent us out. As played, the game calculates whether or not the hit actually did any damage, etc. A lot of events in my game were being handled in the animation updates. I'm not sure if this is good practice, but whatever. I've also given the player the ability to use a shield. The game also does hit detection on a shield, and you can see here for enemies like these rats, it pushes the enemy away from the player and also makes them circle around to the other side of the player. Because if they can't get close enough to attack, then why would they? Spent a little time thinking about how the hitbox for the shield should be, because when I start adding projectiles to the game, you know, baseballs and frying pans and stuff, I want there to be a good balance between the shield being able to block arrows and crap like that, but also allow projectiles to pass through tiny areas. As far as damage reduction, I don't think I'm going to use hit detection against the shield for melee combat, because I foresee things like a sword passing through the entire player's bounding box from the other side, just barely nicking the shield, and then that registers as a block. So probably just do a quick calculation of whether or not the player is looking the same way as the relative angle of the enemy and reduce the damage from there. But it's something I will think about. I can think of some solutions, but they all seem overly complicated at the moment. And finally, the game has blood, beautiful, glorious blood. So the way I programmed the blood is that about half the damage hits will leave a blood pool. During the blood animation, the blood is drawn in front of the entity, but once it becomes a pool, it's basically drawn behind all the entities in the game, but above the floor, textures, and this seems to look right. I've also started to optimize the draw calls so that when an entity is off screen, it doesn't get drawn. I did this because it felt like the game was slowing down quite a bit, but I actually had an error in my drawing code that was causing everything to be drawn hundreds of extra times. I looked it up, and with Allegro and hardware acceleration, you should be able to get away with drawing 16,000 sprites or something before the game starts to slow down. Still, I'll probably continue optimizing the draw calls by whether or not they appear on screen, just because it's a simple thing I can do, and if you start stuff early on, it's not that difficult going forward. Well, that's about it, I guess. I also wrote a couple of pieces of music for the game. They aren't in there yet because I'm having trouble with the sound engine. After a certain point, it starts cutting off sounds randomly, so it's another thing to fix. My goal for next week, I'm not sure. I'll either continue working on the UI stuff, or I'll add a crossbow to the player, or maybe make death animations. I just want to get much basic stuff done as I can before I start creating more assets for the game, so that I don't have to go back and redo stuff later, because it's always a painful process.